We are now going to be looking a little bit at the concept of solubility and the formation of solutions, and later on the concentration of solutions. So a solution is a homogeneous mixture. So it's a combination of two or more substances in which each substance retains its own chemical identity. So it's not a chemical process, it's a physical process. When you mix water and salt, there will be an interaction between the molecules of water and the salt, the ions and salt, but you will still have chemically the same compounds, NaCl, but separated in case of these ions and the compound water. You don't make a new compound. You talk about solute and solvent, which is solvent is whichever component of your homogeneous mixture that is present in the greatest amount, typically water in water in aqueous solutions, and solute are the compounds that are present in the smaller amounts compared to the solvent. Solubility is how much of a solute will dissolve in a certain amount of solvent, per liter, per kilogram, per whatever. And it changes with temperature. So the temperature will affect how soluble a compound is. Typically, solubility increases with temperature for many compounds. And if you think, for example, when you dissolve sugar in cold coffee or in hot coffee, you notice that it takes you longer to dissolve it if the liquid is cold, and the hotter, the warmer it is, the easier it is to dissolve. That's not always the case. For example, gases dissolve worse in hot than in cold liquids. And if you think of, for example, boiling water, if you look at a kettle when it's boiling water, and you see that a bit before it starts boiling, you see some bubbles forming, that hits around 80 degrees. And that is when the solubility of oxygen, the oxygen in the water, oxygen dissolved in the water, is low, and the molecules of oxygen are escaping the water, and that's around 80 degrees. So solubility changes with temperature, and when you give a solubility value, you give it at a particular temperature, and in many cases, increased temperature increase solubility, but not in all the cases. Sometimes an increased solubility, for example in gases, the higher the temperature, the lower the solubility. And finally, you're probably familiar with the concept that like dissolves like. A solid will dissolve more easily in a solvent if it has a similar chemical structure to the solvent. And more about that in future slides. When you have a solute in a solvent, when a solute dissolves in a solvent, we call that a solvation process. And solvation is the process of the surrounding of the molecules of solute by molecules of the solvent. And you can sometimes have the formation of an electrolyte, which is when your solvent surrounds the molecule, the atoms of solute, the substance splits into ions, and then you have a conductor of electricity, or you can have solvation with with the formation of a non-electrolyte. The substance gets surrounded by the molecules of solvent, but it doesn't form ions and it doesn't conduct electricity. And when an example of an electrolyte would be when you dissolve the compound salt, table salt, sodium chloride in water. It dissolves and it forms ions of sodium and the chloride anion. So you still have salt, but it's split into its ion, and that's a solution that conducts electricity, is an electrolyte. And because water is the solvent of life, and it's very important for us, and we spend a lot of time looking at the behavior of chemical compounds in water, the specific act of the molecules of water surrounding a solute, we call that hydration. So hydration is when molecules of water surround a compound, a solute, and it gets dissolved. So when will a compound dissolve? When will a solute dissolve? Well, for a solute to dissolve in a solvent, for example, let's talk about water, the interaction between the molecules or the ions that make the solvent and the molecules or ions that make the solute have to be stronger than, similar or stronger than the interaction between the molecules of solvent or the molecules of solute. So we have here an example of, again, we're going back to sodium chloride, and we put it in water. And I put in the water in top of the arrow. It's not reacting with the sodium chloride. It's not a chemical reaction. It's just you are dissolving the sodium chloride in the water. So what happens? Well, it happens that the bonds that keep the attraction that keeps the sodium and the chlorine atoms, or the sodium ions and the chloride ions together, is weaker than the attraction that you get between the ions and the molecules of water. And I've got here a drawing of how the molecules of water will surround. If you think of the oxygen, and these are to the hydrogens, and we talked about how the oxygen is very electronegative. It pulls from the electrons from the bond, and that means that it has a strong partial negative charge. There is a lot of electronic charge around the oxygen, and that makes it feel attracted to the sodium ion. And if you think of the molecules on the other side, so you've got the hydrogens here, and the oxygen, and the partial negative charge in the oxygen and the partial positive charge in the hydrogen, it comes around the chloride ion, but it orients itself with the hydrogens pointing towards the chloride ion. So because you have this polarity in the molecule of water, because there is a separation of charges, because oxygen is more electronegative and attracts the electrons from the bonds with the hydrogens, so there is a concentration of electronic charge around the oxygen. So you have a section of the molecule, the oxygen, that has a partial negative charge, and a section of the molecule, the hydrogen, that has a partial positive charge. It lacks electrons. It comes around both ions, the chloride ions with the hydrogen side and the sodium ions with the oxygen side. And those interactions are stronger than the interactions that keep the molecules of water together and the compound NaCl together. If they weren't stronger, that would not happen. But because they are stronger, there are stronger interactions between the molecules of water and each of the ions than the molecules of water kept together and the NaCl kept together. That's when the solvation, the hydration process happens. As I mentioned in previous slides, solubility changes with temperature. At a particular temperature, there is a certain amount of solute that will dissolve in a particular amount of solvent. And you give solubility in grams per liter or milligrams per liter or per milliliter, some sort of unit of how many grams or kilograms mass of that solute will dissolve in a certain amount of solvent. And at a particular temperature, at 25 degrees, at 30 degrees, at 10 degrees, etc. When this condition occurs, when you have as much solute for that particular temperature, as much solute as you can in that amount of solvent, you call that solution saturated. It means at that temperature, that solution has as much solute as it can possibly have. And that doesn't mean that it's a very concentrated solution or very diluted solution, because that will depend on how easy you can dissolve that compound. Some compounds dissolve more easily than others. It just means saturated is for that particular compound, for that particular temperature, you have as much compound in that solution as you could possibly have. And saturation changes with temperature because solubility changes with temperature. If we continue adding solute after the saturation condition has been reached, the solute will start coming off of the solution and will start to precipitate, and you will start getting your solid in the compound, if it's a solid, back in your beaker, in your container.